Okay, so before we start with the recite doa Ummul Kitab Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin arrahmanir rahim maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in ihdinas siratal mustaqim siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. So first thing first, welcome back Prof Nata to join this session. Okay, and also our friends and student from SONGKLA University. Okay. And also for the student of UTeM, Universiti Teknikal Malaysia Melaka, for having this afternoon session for the presentation regarding the task related to the extended abstract. Okay, so if you can see from the sharing screen, it should be the main of ceremony is the Associate Professor Dr. Muhammad Ridwan bin Ahmad. But unfortunately, he's not well. He's affected by the COVID. So that, as usual, me myself will replace as a MC for this afternoon session. And then followed by two judges or panel from UTeM. But then Professor Dr. Muhammad Rizal bin Saleh also not available. So just remain one panel or judges, which is me myself, Muhammad Afzal Nazar Rosli, on behalf of UTeM. Okay. And then I think from the part of the PSU, Prof Nata will be the one of the judges, correct?
Yes, yes.
All right. You only the one, or you have another company? I mean, your colleagues, everyone?
Actually, Dr. Apidet.
Oh, okay.
Yeah, I called him.
So, okay, can you jot down his name at the chat box, Prof Nata?
Okay, moment, please.
Yeah, sure. Take your time.
Let me find chat. Oh, I got.
Yeah. Dr. Apidat. Okay.
Yes.
Okay. Hold on.
You want family name or just the name is fine?
It's okay as long I can mention his name correctly. I mean, pronounce it clearly, then it should be okay. Dr. Apidat, right? Apidat. Hello? I think we will go this way. We have 8 groups, and then we will present alternately. I mean, maybe first group from UTeM, second group from PSU, and then third group from UTeM, and vice versa. Okay, so I think that is very clear. Just to brief you guys what we have gone through for this afternoon. Each group will be present their task only 10 minutes. Okay, and then 2 minutes for the Q&A, question and answer, if any, or maybe if no any question, maybe just a recommendation or suggestion. So it depends how it goes in terms of your presentation. And then all this part will be recorded, and I think the most appropriate way we will announce the winner during tomorrow's ceremony. I mean, during the closing for tomorrow. Okay, first, second, and third, which is held by tomorrow morning. Okay, so meaning to say, today the panels will evaluate your presentation, and we have the ample time as well because we have recorded your presentation as well, so that we can have cross-check again or whichever things we are missing, then we can have that kind of resources to look it back later, to make it fair enough for everybody, inshallah. Any question, guys, before we start? So I stop sharing. Okay, I will open the question first to the Prof. Nata. Is that clear, Prof. Nata, regarding how we will go this part, this afternoon
Yes,
session?
yes, yes.
Okay, great. So, can I heard anyone from PSU student? Is that okay, guys?
Kitip, Varisara and Kitipat.
Oh,
Thank
okay.
you for
Marusna and Kitipat.
Varisara. Varisara.
Oh, okay.
I'm not sure for other group because now we are a little bit in flooding
Oh,
condition.
okay, correct. So,
I cannot see another student yet.
okay, it's
Just
okay,
two.
So, uh, me myself, on behalf of the UTeM student staff, on behalf, convey the condolence to the PSU, especially those who are residents somewhere nearby the HATYAI or the SONGKLA, those affected by the flooded, Prof. So hopefully everything goes well and recovery soon. Okay. All right.
Thank you.
Okay. Okay, with no further any delay, I think I will just follow according to the schedule. I would start with the team from any volunteer. Okay, so this is the very crucial part. Volunteer. Volunteer. Any volunteer? Group volunteer to start first. If not, if not, I may start with the group. mm, Check the handphone. Who the first submission? Okay, Farahin want to start first. Okay, Farahin, from FKEKK. Okay, good of you. You may share your extended abstract and then just to give a brief explanation. Okay. Okay, shall we start? Farahin and team. Team FKKK. Alright. Wih, ini share on share. Farah. Anyone from FKKK? Hello, Farah. We can't hear your voice.
Sir,
Yes.
approve another account for Rahim.
What? Approve?
The request
Request?
ada 2 account.
Oh, ada 2 account. Kat mana pula nak request ni? Sekejap.
Ada request.
Hmm. Ada pula. Sekejap. Hold on eh. Apa? Para join meeting? Betul? Aman? Hello?
Okey, dah.
Alright. Okay, Farah, the floor is yours. You can start when you are ready.
Hello, Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Tak, aku tak boleh kat sini. Okay. Sorry everybody for taking a bit long time to present my journal, representative FKEKK faculty. Okay, so this is our journal titled on a comparative study of deep learning parameters for ARCUS analysis classification. Okay, so for the abstract, we are starting the abstract from the introduction, the general introduction of our research, starting from here.
Farah, sorry. Farah, can you enlarge your view? Can you enlarge your view?
Enlarge my view.
I mean, just increase the percentage too.
Okay.
Alright, okay.
Okay, do you guys see my sharing the
Yes.
journal? Okay. So for this journal, we are starting our journal with the abstract, starting from the introduction, the general introduction of the journal, starting from here to where? Okay, until here. So this is the general introduction of our journal. So then we proceed to the objective of our research is this one. This one. So next, from the abstract, we continue to the methodology, the general methodology of our journal, starting from here until here. And then we proceed our abstract into the general result of our journal, starting from here until here. And then we proceed until to the conclusion and the future work. So this is for the abstract. So after the abstract, we move to the introduction of our journal. The introduction starting from here until here, and then we move to the related work based on our journal. Related work, and then proceed to the methodology. 3.1 dataset, 3.2 image processing. So this is the methodology. Basically, is the general overview of the flow of the methodology of our project, starting from the dataset, collecting dataset until the model, until the evaluation. And after finish the methodology part, we continue to the result and the discussion. The result and discussion is based on this table. Table 2, table 3, table 4, and then next is we conclude the journal into one paragraph with the supporting table from table 5. And then lastly, the references. Okay, that's all.
All right, thank you, Farhin, for the presentation. So I just want to ask one question, a quick question only, Farah. Can you go back to your first page?
Alright.
Okay, and then try to scroll it a bit down. Okay, a bit. Okay, a bit. Okay, I try to enlarge it. Okay, okay, hold on. Okay, and a bit lower. A bit higher. Okay, stop, stop. Okay, just nice. Okay, can you share with us what is your intention to give the subtopic of the introduction and also the related work? So how do you differentiate this kind of sentences or statement? Because normally they will go for the background of study, they will go for the merging in with the introduction, but in this part, you are trying to do two separate storytelling, which is introduction and related works. So can you just share with us what is your idea for having this kind of option?
Okay, so the idea of this journal is actually based on the title, the comparative study of deep learning parameters for ARCAS English. So the introduction, it will start the general introduction for the deep learning parameters for ARCAS English, which is I make a story about technological advancement like deep learning technique. So I make it the story of my journal into a general introduction. Start with the general introduction here, and then continue to the to the next research, no, to the next story, which is the hyperparameters part, the parameters here. So actually I start with the ARCAS analysis first, the general introduction for the ARCAS analysis, then proceed to the parameters, deep learning parameter story, which is at here. I don't know, this one here, the hyperparameter story. With the hyperparameter story, I include with the apa tu? The references from previous journal like Smith and Banjo. And this is the story from the previous researchers on parameters part for ARCAS analysis. That is for the introduction, the story of the introduction. Basically, that is for the general part. It's story for the general part of the ARCAS analysis and the hyperparameters. Okay, so for the related work, I story about the previous researchers about on the deep learning about for ARCAS analysis classification on the related work, and then the related work proceed on the related work proceed with the result of the paper. Like I mentioned, is this related work proposed by Banawati, they gain 97.45%, and then for the Mundadi, they gain the accuracy for 89.92%, 94.8%, and that is for the related work on the deep learning parameters result based on the previous researchers.
All right. Okay, thank you, Farah, for explanation. If any question from Nata, if any?
Yes, that means in this paper, you propose methodology and it's okay. You use the data set from like UV risk, right?
Yes. I use the dataset from the
And
UB.
how you compare to other or compare together with another
researchers.
Yeah. Could you go to the comparison for me?
So the comparison is, I didn't state it on the result for the previous researchers result, but I mentioned it on the related work.
Okay.
This one. So I mentioned it all the previous researchers result, which I'm comparing the parameters they are using, like 0.01, the learning rates parameters. So I'm comparing the result of the accuracy.
Okay, thank you.
So at the result, I'm just stated my accuracy, the best accuracy that I gained from the best learning rate parameters. That's all.
Okay. Thank you. I understand table 2.
Thank you, Dr. Nata.
All right, thank you for your presentation, Farah. On behalf team from FKKK, congratulations.
Sorry, I'm
So,
Abhidek
but
from.
wait for until we finish, Farah.
Okay, you finish.
Dr. Apidet, sorry, Dr. Apidet has some question.
Okay.
If
Okay.
Dr. Abhidek, if any question?
Yes, I have
sorry.
one suggestion. Please go to the section related work.
Related work, all right.
I like your information, but in my opinion, if you summarize them into table, I think it easy to understand. It's good for it is good for reviewer to check your contribution.
I got that. Actually, I got the table, the comparison table for the previous researchers, comparison between the previous researcher and mine, but I didn't state it on the journal because it's too much to put inside this tiny journal.
Okay, I see.
This is just a simple journal of Earth, so I just present the simple one.
Okay. Thank you, Farah, for the response, and also thank you for the panels from Nata and also from Dr. Apidat for the good question. So next, we go to the team from PSU. Any group from PSU want to share or start?
Marisara will present, please.
Directly mention her name.
Yeah. I think now we has only her and Kritipat.
It's okay.
We contact. Thank you for joining us, Marisara. And could you share your result?
Okay, thank you. Okay. You can see the slide.
Yes.
Yes. Okay. Good afternoon, everybody. My name is Ruslana, and today I would like to present my topic is a study of water quality evaluation for sea bass culture in case using data grouping techniques according to culturing areas. Now we're going to start in first topic introduction. In your sub-district Songkla, Thailand, in recent year, the fishermen found the problem of sea bass culture increase are the death of sea bass and the growth of sea bass is decreasing. The main cause are the lack of oxygen in the water because water quality is motivated by the changing environment. So water quality evaluation able to solve the problem. Water quality assessment rewards that a good water quality assessment require considerations of all factors affecting water quality, such as pH, dissolved oxygen, and salinity. This non-linear in water quality data is called using water quality data from various area and environment change. Our paper used neural networks method to improve the effectiveness of water quality assessment based on uncertain sensor data to fill data from various water quality sensors to obtain water quality level and use principal component analysis or PCA method for pre-processing data to analyze the composition of the data and to reduce variance of data. This paper study method for assessing water quality that is suitable for the aquaculture of sea bass in case. And the next topic is water quality data. With this data come from the Quota Aquarium Technology and Innovation Research and Development Center 6, Songkhla Province. Figure 1. From Figure 1 show the area of collecting water quality data and and Figure 2. And Figure 1 from the graph show the dissolved oxygen value since 2020 to 2027 of all village. It's found that July 2021, the different area will have the different DO value. This I show this is a Figure 1, and this paper used 6 features of water quality for classify show as table 1, such as them, transpiration, transparency, temperature, sanitary, pH, and DO. Experimental setup. On this information up at this block diagram process on the Figure T is the proposed method. First step, input data from 6 feature water quality from the sensor, and second is grouping data. Third is pre-processing for select 3 feature data. Fourth is fusion sensor for classify, and the final step is output data. The output data are the card of water quality. This paper has the 3 levels of water quality. Level 1 refers to the good water quality. Level 2 indicates that water quality is under surveillance. And level 3 refers to the condition within the dangerous criteria. And the result and discussion. Table 2 show the mean square error of training model, half of the vice model and original data from the all village data, and zone 1 from the zone 1 data, and the zone 2 from the zone 2 data, and the zone 3 from a zone 3 data, and the zone 4 from a zone 4 data, and the mean square error from the original model has low. Okay, and the table T show the result of accuracy model from the 5 model and the original and is zone model, and the accuracy of the zone flow is 94.8 is at a higher accuracy when compared to the original model. For the summary, from the experiment to good water quality according to the zone of similar area is was found that scooping could reduce the variance of the data, and the mean accuracy of original model is 88.9%. The mean accuracy of model for each zone was 93.40%, which is a 5.09% increase over the original model. The water quality data were divided into four groups according to neighboring, clustering, area effects, water quality evaluation, and the last one is reference. Thank you.
Okay, thank you. Who's on the line? Oh, Warisara, right? Warisara.
Yes, yes.
Okay, so we open for the Q&A session. Maybe from Prof. Nata or from Dr. Erica.
Yes. Varisala, could you go to the introduction?
Okay.
Yes, in the introduction, the first paragraph is your problem statement, right?
Yes.
And the next paragraph is the review.
Yes.
And how about the final, the how you claim your method, your contribution in this work? Could you go to the last paragraph of the introduction?
Okay. In the
In this page.
future,
Go down or up? I don't know. I'm not sure. Yeah,
okay.
introduction.
Okay.
The last paragraph of the introduction. Yes. Okay. So could you summarize in your word that what the contribution or the new that you propose in this paper?
Contribution is the have a model for the evaluation water quality for the seabed in case using the fusion sensor and reduce parameters for the reduce the parameter for the evaluation water quality.
How you compare, because you use PCA, how you compare the PCA from reference 12 or 13? How?
The PCA from the
Because because use the same technique, right? What the new that you add in your paper?
The new PCA in the paper 12 and 13 is not select some parameter and some, and this paper my paper is select the some parameter for fusion sensor.
Oh, I see. Thank you.
Thank you.
Thank you, Prof. Nata, for the question and also the response. I open to the Dr. Apidat, if any question.
Yes, I have two questions. Okay, Warisara. Okay, Warisara. First of all, thank you for your presentation. This is so interesting work. I also have agree with Professor Natha about the introduction section. Please summarize the different and related work. State one paragraph inside this section. Okay.
One paragraph.
Yes, please add one paragraph about the difference between your work and related work in the introduction section. If you do like this, the reviewer will understand your contribution and novelty.
Oh, okay.
This is my suggestion. Okay, for my second question, what is the major limitation of your work?
อันเกรนสปีดอาจารย์คือเสียงมันกล้องเหรอคะอาจารย์
Okay. My question is, what is the limitation of your work?
Oh, okay. Now I edit process for the fusion sensor and use the correlation for the find the base parameter to the find the base parameter for the fusion sensor, and everything is a dissolved oxygen value and correlation. That simulation parameter is the everything to the dissolved oxygen is the temperature and salinity. I use the temperature and salinity value for the fusion sensor for the evaluation water quality in the future.
Okay, I understand. So please provide this information in the conclusion section as a future work. Yeah, I'm okay. I understand the limitation of your work now. My last recommendation, you choose put this information in the conclusion section. Okay. Okay, thank you very much.
Thank you.
Okay, thank you, Dr. Atidat, for the question. I just want to ask one quick question. Is that okay, Warisara?
Yes.
Okay, be calm, no problem. Okay, based on your works, you are mentioning you are doing the so-called assessment, right? Assessment for the water quality.
Yes.
Okay, so can you share to us what standard or what reference you are referring to assure that water quality it exceed or not based on that standard? Is that any standard you are referring to get the, I mean, the condition of your water, because you want to assess the water, right?
Sorry, again, please.
Okay, you are doing to assess or to evaluate your water quality, correct? Okay, so what standard are you referring to know that your water quality is exceed or not exceed the allowable limit? Is that what standard? Maybe the Thailand standard, I don't know, maybe the
Okay.
water quality, I don't know, just to ask randomly.
You want the standard for the water quality? Yes.
Yeah, correct.
Okay. This is standard water quality. I come from the Fisher Center of Thailand, and dissolved oxygen value for the divide card water quality from the information from the Researcher Center Songkla.
Coastal aquarium technology, right?
Yes.
Yeah.
Okay. Okay, I think that's all from us. Warisara, thank you very much. Thank you for your presentation.
Thank
Thank you
you.
very much.
Okay.
Thank you.
Good
So,
job.
the more question, the louder. All right, so we go for the turn of UTeM. Maybe we can start with the Faculty of FKP. FKP team.
Okay, Doctor.
All right, so tell
We'll
us when you are
see.
ready, then you can start your presentation.
Okay. So, my name is Gan, and today I would like to present my poster, something like that. So, my group title is the finite element analysis of vacuum chamber for vacuum assisted FDM system. So, in this project, we would like to design a vacuum chamber especially for the fuse deposition modeling FDM. So the inspiration for this project is okay. We start from the additive manufacturing. So we know that AM is one of the methods that to construct the visualization model for product. So it's very good in applying the AM in the industry in order to reduce the time and cost and human engagement and product development. However, they also has some problem when applying the AM, which is the dimensional inaccuracy and full surface quality. So the post-processing will be require time and high cost, and it may be generate the hazardous for some process. So in order to eliminate this possible hazardous, so based on the literature review, we found that we can develop a vacuum assisted FDM. It's very useful because it will create a low pressure environment for the FDM process. So the main problem can be solved is like the air density molecule will be less than the one at the atmospheric state. So the conventional of the heat energy is very difficult to take place. So it will eliminate the rapid cooling, which will lead to the stress and distortion. So this is our inspiration to develop this project. Okay, so we go to the methodology. So the first thing is to material selection. So the material we select is the archive. So we choose this material is because it has a great elastic modulus and tensile strength and yield strength. And the most important thing is this material is transparent and lightweight. So it will be easy to take away something like that. So we talk about the design. So the chamber is, you can see the schematic diagram. So the chamber is 500 mm in length and 700 mm in width and 800 mm in height. So the thinner is 20 mm. So this size of the chamber is able to design for to withstand the working pressure up to the 60 megapascal. So this is a design for the So the one of the wall have two holes to attach to the pressure relief valve and one for the vacuum pressure valve. So the chamber will be designed with two doors to access the breathing bed and the filament area of 3D printer. And the door will be attached with the door latch to ensure it will fit well with the frame and the hinge to ease the opening and closing. And the most important thing is we will be a rubber caster still at the both door to ensure the door is fully tight to the frame to secure for the vacuum situation. Okay. So after that, in order, we need to test is this chamber is work or not. We calculate based on the safety factor, which is determined by the formula is shown in equation 1, which is yield strength over wall stress. So we go to the result and discussion. So the solver is used for the simulation. So we can see for the figure 2, we obtain that the wall stress with maximum 5.198 Pascal, which highlight in the right circle, but the yield strength is lower with 4.5 Pascal. So this will cause the deflection toward the model because the yield strength is lower than the wheel stress. Yeah, so at the right circle there will the body frame will be stacked. So we are causing the compressive force to exerted on the structure. So in order to determine how many the displacement, the deflection, so we going to the displacement simulation. So we found that at the right circle area, the wall is experiencing 32.38 mm deflection. So we also can be concluded maybe due to the at the center of the wall, it will be no support or less. So it will be easy to deflect. So it can be concluded it is the weakest point of the chamber. So we also calculate the safety factor. So we obtain the value is 0.086. So which means that the value safety factor is less than 1, indicate that the model is very dangerous and very not suitable and can't withstand the 60 megapascal. So we need to further improve the model again. So go to the conclusion that we found that the warm stress has a higher value than the yield strength value. So the safety factor value is less than 1. Then we need to improve again the model. Yeah. So that's all for me. Thank you.
All right, thank you again on behalf of FKP presenter. So that I open to the panel if any question or recommendation.
I have only one
Okay, please,
suggestion.
after that, no problem.
Can you hear me now?
Yeah, yes, we can
Yes.
hear you.
Okay. So how can I call you? Like the presenter. How can I call you? You know is
Just call me Gan.
Gan, right? Okay.
Yeah, yes.
Thank you, Gan, for your presentation. So
Okay.
actually I have no question regarding your work, but just only suggestion, because I have seen in the head note of your paper, look like it is from conference, right?
Yes.
Yeah. So for generally your work like this, it is acceptable for the conference. But if you would like to submit your paper, your work to like in the higher ranking journal, like in Scopus or ISI like that. So normally for using SolidWorks software for predicting something in academic researcher, sometimes we not like we not accept, it is not acceptable for modeling using like a SolidWorks, because what like in SolidWorks like it has like a black box. It is some many black box. So you,
Understand.
just like how can I explain? Like a software try to define the problem to be like try to simplify the problem like that. So sometimes we could not like do not know what like our result is correct or not, something like that. But in terms of commercial using like in industry, something like that, it is acceptable. It is okay for that. And then this is my only my suggestion, first suggestion. So if you wanna submit your work in high ranking journal, maybe you have to search like software. It is like better than that SolidWorks like that. And second is for the modeling, first we have to vary our grid generation, grid number. Yeah. So for this is very like a compulsory for publishing our in simulation paper. And second, we have to have like data validation, like from our work to like empirical correlation or some like experiment result like that. Yes, this is only my suggestion for improving your work. Thank you.
Okay, thank you.
Thank you,
Thank you,
Dr.
Dr. Akibat.
Mokhtar.
So,
Yeah.
if any from Pranata?
Yeah, I have a simple question. Could you go to the abstract? Could you enlarge a bit?
Okay.
Yeah, I can see now. In the final sentence, you summarize that. Therefore, by using static analysis, I agree with Dr. Mokhtar that maybe this time we just training, but in your real work, I think you can do dynamic analysis with some tool, another tool. I think your work will have high impact. Yeah, that's my suggestion.
Okay. So just like adding some experimental result to compare with the simulation. Okay.
Yes. Thank you.
Okay, thank you.
Thank you, Prof. Nata. Okay, again, I suggest very real quick suggestion. First thing first, when we are dealing with the simulation work, especially for the solid work or other simulation works. So I think at least we need to have maybe 2 or 3 line at least story about the machine, because the machine will give you the huge difference in terms of your accuracy of your result. That's first thing. Okay, and then secondly, can you go to the last pages again? I mean, your conclusion.
Conclusion, yeah.
Conclusion. Okay, conclusion. Normally we will story about the good things. Okay, the good things. In your case, you are mentioning you are not meet the requirement. Okay, and then 0.086 safety factor, which is very low, right? I mean, almost not have the safety factor. So,
Yes.
okay, in other way around, before you go until the extent, maybe try to so-called redo the simulation work, everything. At least it meet the basic principle of the safety factor. Then you try to go for your writing or publication. It gives you more chances. We know this is the preliminary study to get what is the going for your simulation work, but then at least you know what is the limit of the safety factor, then you try to design according to the allowable safety factor. That is my humble opinion, kan?
Okay. Thank you, Doctor.
Okay, thank you, team from FKP. And then we turn back to the team from PSU, if any.
From PSU, I'm very sorry that I cannot
No?
contact
Okay, it's okay, it's
student.
okay. Then we proceed with the team UTeM.
Yeah, one tell me he's
It's okay, it's
in
okay.
flooding condition.
Alright, no problem, no problem,
Yeah,
no
because
problem.
yesterday yesterday have heavy raining, many guy cannot join.
Okay, alright, it's okay.
Sorry for that.
Sorry, I would like to suggest Kan.
Sorry, Dr. Abhinav. Okay. Any things you want to raise? I mean, concern about the previous presentation.
Yeah, Kan.
Jan,
Thank you
can
very
you
much
share
for
back your slide, Jan? Your paper?
I'm okay. Just a simple suggestion.
Alright.
Kan, please rewrite your reference format. I think all should be the same. First, and the second, for the equation 1, the ratio you show in the paper is yield strength, right? Divided by strength.
The equation, right?
Yes, equation 1. Equation 1 is yield strength divided by strength, right? Please define the meaning of this equation. I understand that this equation is chamber safety factor, right?
Yes.
So please add chamber safety factor inside the equation 1.
Sorry.
Yeah, this is my recommendation.
Okay. Gan, I think so. We try to repeat what Dr. Apidat tried to mention. Your equation 1 seems like suddenly appear without any detail of the safety factor equal to yield over verbal stress or something like that. Is that that's you are trying to say, Dr. Apidat, right?
Yeah.
Suddenly it's appear equation 1 okay, without knowing the detail of that equation 4. I think that's the concept from the Dr. Apidat.
Yes,
So
and the
it will be
second
like
and my second suggestion is please rewrite the reference format, because the reference 1, 2 are different from the different 3 and 4.
sorry.
Okay, please go to the reference format.
Okay.
Yes, I'll choose be the same. Okay. Okay, if you notice, reference 1, 2 are different from reference 3 and 4. So please use the same format. You should select only one format, okay, and rewrite them.
Okay, and that's okay. The format for the reference different, right?
Yeah. Okay, thank you very much, Kan.
Okay, thank you.
Okay, thank
Sorry
you.
for missing you for a while.
I'm okay. Thank you so much.
Yes. Because Dr. Makta Joy, he
Okay, yes.
finished moving stuff from the flooding and he come to join us.
Yeah, no problem. I think that is the compensation. The less team enter, but the more judges enter.
Yeah. He
There should be
informed
no
me
problem.
in the morning he have to move his experimental equipment
Okay.
to higher. Yeah.
To secure the experimental
Yes.
Yeah. like draining is slow down now in
Okay.
our place, but some water is coming from other place.
Oh,
Oh, all right.
Mm.
Okay. Okay, Gan, you can stop sharing your paper and we give the opportunity to the next group from UTeM. We may call upon a group from FKM.
Okay, thank you.
Okay, welcome. Who will be present?
Hello, good evening.
Who's on the line? Oh, okay, Fakrul. Okay.
Yep.
Okay, Fakrul, the screen is yours.
Right. Bismillahirrahmanirrahim. First of all, I would like to appreciate the time for the panel to be here on my presentation. And the title of my presentation is as stated, it is about performance evaluation and a validation of a dual plate slider throttle body. I would like to first introduce that this is a research on the area of automotive engineering. It is about components in the engine which are called the throttle body, whereby the conventional throttle body now is been using the type of butterfly valve throttle body, which allow the air to enter the internal combustion engine to combust and to move the vehicles. So in my research, it is about a new proposed in terms of the design of the throttle body, whereby I propose to eliminate the butterfly shaft and to suggest a new slider type throttle body, which namely as a dual plate slider throttle body, DPSTB. This DPSTB will be evaluated in my paper in two condition, in two parameter that are stated in my paper that I'll go through after I go through to the introduction first, right? So in this introduction, it is known from the previous researcher, which Balaji and Storage, that explain how the butterfly throttle body, BTB, are suffering of pressure loss in the performance. And it is supported by the effort done by previous researchers. They are introducing the type of slider throttle body that are also being used in high performance vehicles, for example, the Porsche 917 and BMW M10, which are already using the slider type throttle body. However, it is used in the type of individual throttle body, where the number of throttle body is equal to the number of cylinder in the engine. Therefore, however, in my research, the slider type throttle body, dual plate slider throttle body, is focused on the single type throttle body to cater the air that flowing into the internal combustion engine. And it is also supported that in the patent registered by previous researchers on the concept of center flow throttle body, which align the effort from other researchers to demolish the butterfly shaft so that the airflow is supplied to the engine in the condition where it is supposed to be, especially in the wide open throttle condition. Therefore, in this study, the methodology I've conduct is by designing and fabrication of this DPSTB, dual plate sorter body, and then the mathematical model was established by using the hardware in loop simulation experiment that I established a second order transfer function that I used to be evaluated in the condition of the rise time and settling time. By utilizing this second order transfer function, using MATLAB Simulink System Identification Toolbox, I applied the step function to the simulation of this mathematical model, and I managed to get the result of the rise time and settling time for the simulation result. And utilizing the prototype fabricated, I've run the experiment that will then validate the result of the simulation. Here in the result, I showed the result for simulation, whereby for simulation, the rise time of 0.49 was observed and the settling time was 0.67 seconds. And this is for the simulation of dual plate slider throttle body. And as for the hardware in loop result or the experiment observation, the result of mean relative absolute error was 2.51%, which are below 5%, and it is concluded as acceptable. And as the result of hardware in loop experiments and simulation is observed, a comparison to validate the result was executed, and the result shown in figure 6. And from previous researchers, result of the rise time and settling time for butterfly throttle body is shown in figure 7. The comparison was made, and it is proof that my proposed dual plate strider throttle body managed to have a faster time in rise time and also a faster time in settling time, where the butterfly throttle body had a rise time of 0.598 seconds, while my proposed dual plate slider throttle body managed to have 0.49 rise time. And also for the settling time, butterfly throttle body achieved 0.743 seconds, and my proposed dual plate slider throttle body managed to achieve 0.67 seconds of time. Therefore, as for the conclusion and summary, it is proof that dual plate slider throttle body concept offer 18% faster response in rise time and also 9.8% faster in settling time, with a good performance and acceptable stability as compared to the butterfly throttle body. Therefore, I believe this research will impact and will improve the airflow of the intake system for the internal combustion engine for the future. That's all. Thank you.
Okay, thank you, Fakrul, for the presentation. So we open the Q&A session for the panel. Maybe this one, we will start with the Dr. Apidat first.
It's okay, it's okay. Thank you so much. Okay. First of all, thank you very much for your presentation.
Thank you.
For my question, you have stated that the PID parameters 6 to 90 for Kp, 0.8 for Ki, and 2.6 for Kd.
Yes.
How to find this parameter and how to make sure that they show the best result?
Hi. Thank you, Professor, for the question. First of all, I would like to explain that the parameter of P, I, and D was obtained by a sensitivity analysis whereby I evaluate all these parameter of P, I, and D, and the selected parameter was chosen by the most minimum mean relative absolute error that I observed
Okay,
in the sensitivity analysis.
okay, I see. Okay,
Yes.
and my second question, please go to table 2.
Table 2. All right.
Okay, from the result, you consider right time and settling time, right?
Yes, sir.
Have you considered overshoot and steady state error of the system?
Yes, thank you, Prof, for the question. Steady state error is shown in this figure 6, where the steady state error of 0.8% is achieved from the comparison, and based on the previous researcher, it is acceptable as the value is very small. It is below 1% of steady state error recorded from the comparisons, Doctor. Yes.
And overshoot?
The overshoot,
Yeah.
since I've been using the second order transfer function, the overshoot was not being observed in this research.
Okay, I understand. Okay, this
Yes,
is
sir.
depend on your system, right? Because
Yes.
plan model is second order, so you don't consider
Yes,
overshoot.
overshoot.
Okay,
Yes,
thank you
doctor.
so much. This is
Thank
very
you,
good
doctor.
work.
Thank you, doctor.
Okay, thank you, Dr. Pidet. So next we go to others panel, if any. Okay, so Prof Nata raised hand. So it should be something
Raise the
interesting want
right
to
hand.
ask.
Okay. First of all, go to the summary.
Summary.
Yeah. The summary and this page, and I'm not sure how we write the performance, because you show 18% faster and 9.8 faster. For the performance, I saw, I'm not sure in your field. I'm in processor performance. It concern is related with the time we represent in the, for example, you rise time, right? The rise
Yes.
time BTB compared to your
TPS TV.
Yeah. That mean you are faster, right?
Yes.
Yeah.
Yes, doctor. So the comparison.
Yeah.
What I've done here is
Can you represent in that your method is 1 point something time faster than not in percent.
Oh, okay.
For example, for the settling time,
I calculate the percentage as I
yes.
minus 0.59 minus
Because you're faster, right?
yes. So it is minus percentage. So I conclude it as a faster. While in calculation
Yes.
it is minus, meaning it is faster from the actual from the previous butterfly. The value
I
is
understand. Yeah. I just mentioned that it would be better if you
fix with the time faster.
Yeah.
All right.
I'm not sure how because the
Okay.
number is, or you invert something.
Okay.
You can
All right.
when you compare to computer, this computer is 1.2 times faster than other computer, something like that. I think if you convert in this point, it's very easy to get the idea or representation the time faster.
All right, I understand,
That
Doctor.
in
Thank you,
my view,
Mahesh.
but I think it must be similar
Yes.
to represent the time.
Uh,
And another question is about the equation 1.
Equation
Yes.
1.
Why the upper side I'm not sure 95, why
Yep.
you do not have like s power 2 something like that.
Okay. It is by utilizing in the MATLAB Simulink, I choose
Yeah.
so that the transfer function is 2 poles and no zeros. When I choose no zeros here, it means I've got the transfer function with 95 only without s. If I choose 10 here, it will be 95s. However, this was chosen because I wanted it to be in the best fits of 99%, which I observed when I put the no zeros in the transfer function. So
It is
the
similar to the BTB. How about the BTB that you compare with?
the BTB is a research done by Abdul Kadir in
Is it
2018.
Is have 0 or
He also used a second order transfer function that not using the zeros, meaning I've benchmarked from the previous research
I
from the
see.
previous researcher.
Yeah. Okay. I just like if you transfer this into digital or implement into the real embedded system or digital controller, that mean you has only like output signal and for the input signal you have to get forward, not multiply by any signals. I just that means you get only one input signal, not the input signal in the past, but in your output you may get one signal, present signal, and 2 signal in the past, something like it. I'm not sure how it go forward if you want to implement into the digital system. Just the notice.
Yes, thank you,
Okay.
Professor, for your notice.
Yeah.
However, I would like to express that this transfer function was created by the movement in the hardware in loop stimulation, where I give the input to the hardware and
The
the
real
hardware.
motor, right? The real throttle, right?
Yes, to the real throttle body, and it moves and it creates this transfer function in the MATLAB and Simulink. Therefore, I believe that your concerns regarding the digital condition, and I take it into note so that it will be maybe being discussed in the future in terms of your concern.
Yeah. Yes. Thank you.
Yes.
Your work is very interesting.
Thank you,
Good job.
Doctor. Thank you, Doctor.
Thank you.
Okay, before I forget, I would request Associate Professor for
Professor
Dr. to ask
Dr.
any question.
Makata.
Yeah, thank you for invitation. Actually, I just have like a small recommendation for you. Like
Yes.
some you see in figure 1 and figure 2, right? So
Yes.
if you can add like first in like a schematic diagram, it is to make reader understand easily like that. sometimes in like a photo, it is difficult to understand.
Yes,
How
but
like a sensor attach something like that. This is, I think, if you make like a schematic diagram first and then follow by photo like this, it is
all
will
right,
understand easily. Yes,
all
this is
right.
for my
Thank you,
suggestion.
doctor.
And
I
second
take
is
it.
if you like for your case, actually I'm not familiar with graph like this. It is only at I have seen it is only like a transient and steady state like that.
Yes,
Transient and steady state like that. So it
yes,
is not quite like how can I say, like there is no something more. I mean like that. If you can like add more parameter for your work,
oh,
like try to search, try to look on that to add more
yes.
parameter for your work. I think you can improve your work to publish in high impact channel like that. Yes, thank you.
Yes, yes, doctor. Thank you for your feedback, doctor. I've taken note on that issues. However, I would like to explain that this is the scope of my research is regarding on the evaluation of the DPSTB, and it is only focusing on the settling time and also the rise time of the DPSTB. Thank you, doctor, for your advice, and I will take note everything. Thank you, doctor.
Yeah.
Okay, thank you, Associate Professor Makata, for your question. Just real quick from Sir Fakrul, can you go to
Yes.
your abstract? Can you show to us where is the one or two lines your problem statement in your abstract?
Right. I begin with an introduction about the situation and then go to the objective of the study. This is a method whereby I endorse the hills. Okay, comparing between result. Okay. I believe Sir Afzal already know the answer. But
Okay. Actually,
maybe exceeded
the thing
the
we need to cross check, Fakrul. I know
yes.
you already stated the things, everything in your introduction. I mean, your aim of the project, what is the issue of the airflow during the throttling valve for the dual plate slider, and then compared to the butterfly type. So yes, we know, but then um, technically we should address at least one or two lines just to get the idea for the reader to follow your works, because they want to know what is the concern, what is the issue you are trying to solve.
Yes, yes.
Right?
Thank you,
And
doctor. Yeah, I
then
understand.
bring all the reader towards your project and result and everything. That should be a very good package of doing the paper.
Yes,
All right.
mashallah. Thank you,
Yes.
doctor. Thank you,
Okay.
your
Thank you very
advice.
much.
Thank you very much.
All right. Okay.
Right.
Tanya banyak-banyak kan? Tanya sikit je.
Jangan.
Okay. Next, we go to maybe for the glass globe. From UTeM, FKE, Faculty of Electrical Engineering. So please prepare your material or paper. All right, hold on. Diana, is it?
I am going to take a cup of coffee, so I will be right here again. Okay.
Don't take so long. We wait you.
5 minutes break.
Okay. 5 minutes break according to the Prof kata. We break for a while, guys, and then we start maybe after.
Okay, Farun, I Mr. Farun, the can I talk to Mr. Farun a moment? I remember how to represent the term.
Oh, okay. Fakrul, can you open your mic and respond to the Prof Nata regarding the concern of the percentage and the gain that
The last page, the summary. Yeah, I just remember how how to do with the time.
Hello, Fakrul. Can you try to
Yes.
share your paper as well?
Okay. I'm trying.
Hold on, Diana. Kejap. While waiting for the from Makassar.
Okay.
Yeah. Could you go to the summary again?
Yes, okay.
I show the example like one computer finish in 20 nanosecond,
Okay.
and the second computer can finish job in 10 nanosecond. We
Okay.
said that the second computer 2 times faster than the first one.
Okay.
So in this point, you can use 0.9598 divided by 0.49, and you can get one something 1.8 times faster.
Okay.
If you represent in this this kind, we can know you can faster than
Okay.
another. Yes.
Alright,
How
thank
many
you.
times, right, Prof? How many times they
Maybe
faster?
1.8 or something.
Times faster than the previously.
Yeah.
I
Let,
mean,
let, let me
it
calculate.
is not in the percentage of presentation. It is on the times of faster. Is it not suitable in the context of percentage to explain
Yeah.
the
Yes.
doctor. Thank you
Yes,
very much, doctor.
because the time cannot. I'm not sure. We not present in present. We present in how fast.
How fast?
Many
Yes.
time. Yes.
Yes, doctor. Thank you very much, doctor. Subhanallah. Right. Okay.
Untunglah.
Kan. Makan somtam lah.
Just my recommend. But if in your view use like this, it's okay.
Thank you very much, doctor. I really appreciate your comment and suggestion. I will take it into my consideration, doctor. Thank you very much. Subhanallah.
Yes. Thank you.
It seems that Dr. Datta like this work.
Actually, Dr. Nata already expressed the interest in during I present the poster. Dr. Nata is
Okay.
my examiner at the time I present the poster.
Yeah.
Yeah.
Because you do the real the hardware in the loop. Yes.
Yes, doctor. Thank you, doctor. I appreciate your advice.
Okay, thank you, Fakrul. Thank you, Prof. Nata. So then we call back again the last candidate from Faculty of Electrical Engineering to share their works.
Okay.
Okay, the floor is yours. You may start when you are ready.
Hello and good evening. Assalamualaikum. My name is Nurdiana Izani, representative from Faculty of Electrical Engineering. And my title of this paper is a simple and efficient methodology in estimating energy losses in distribution feeder. So I will start with by explaining a brief review of.
Diana, could you enlarge your?
Oh, okay. Sorry.
Yeah. Thank you.
Okay, I will start with a brief review. So, as we all know, energy efficiency is important for us to reduce waste in order to sustain in a sustainable development, for us to reach the energy sustainable development. So energy losses is actually a measure of how efficient the power will be delivered to its customer. and somehow it may deteriorate network performance and energy efficiency. So it also if we know about the emission gases is actually the excessive emission generated by fossil fuel power plants, and it may lead to energy losses since it may cause higher greenhouse gases emission. Thus, if we enhance the power loss, the efficiency of power distribution system will be enhanced too. So therefore, it is very important to accurately quantify the technical losses, since it needs a huge amount of data, and it is a very challenging undertaking for us to estimate the losses. And we need a huge effort to model the entire distribution network. Distribution network is very vast. So okay. So from my abstract, this one is my abstract. So from here, this one is my aim. Means to create a simple and efficient method to calculate losses. Okay. This one is my advantages and my benefits and my significance of study. Means I want to develop a simpler and more efficient method to estimate losses. Then this one is the methodology that I use. Okay. First, I use a base case feeder and peak power loss function. And then I use a case study for me to analyze what method that I propose. And next, this is the result. My result is I aim to achieve a smaller than 10% deviations. And lastly, this is my conclusion. Okay, this is my conclusion. Okay, then that one is for the abstract. Next, for the introduction. Okay, for the introduction, like I said, the energy losses is important for us to estimate. Okay, because if we enhance the power loss again, the efficiency will be enhanced too. So energy losses also is important because it relates with the cost to the customer. If we have a high losses, we may pay high electrical bill. Okay, so it is very important. So this one is traditionally for the past for like work that have been in Malaysia. Okay, in Malaysia there are works that have been done from past researchers, but the existing losses estimation is their model is only their model have limitation because it is based on direct method and not very detailed. So it is hard for us to examine which one to take, which one for us to find, because it's hard to examine because it is very vast, very large. Okay, sorry. Okay, then so my aim is to develop a simpler method using composite load profile, representative composite load profile, peak power loss function, and energy flow model using base case feeder. So you move on to the method part. Okay, for the method part, firstly, I actually collect the data from TNB, power resources in Malaysia. First, I collect the data, and then the second one, I estimate the feeder section load profile. And then this load profile in easiest way to understand is actually I take a load profile and then like I take the average of load profile in Malaysia, and then I considered their the area of industrial, commercial, and another one, industrial, commercial, and what? Sorry, I forgot. I take into consideration about the load profile in different areas. Okay. And then for the next method is I find the peak power loss characteristic using a base case feeder. So this is the figure of the base case feeder. This one I use 11 kilovolt copper cable and three core cable for this base case feeder. So from this base case feeder, I can develop the regression equation using Big Silent Power Factory software. So from there I get this regression equation, and this equation can be used like first method is the load profile. So this load profile I can examine the peak power demand. So peak power demand I can put in this equation, and then I can find the peak power losses easily. So that is the method that I use. And then for the results, I use a case study. So this case study is an actual data that I get from a certain area in Malaysia. So I use the method and to find the energy losses, and then from there I get the energy losses for line, feeder line, and transformer. And then this one, okay. And then I compare my calculation with simulation using Big Silent Power Factory also. So I compare the result between estimated and simulated. So this is the result that I get. And the differences that I get is this one, 6.77%, which is less than 10% that I get. So that's all. And for the conclusion, so the results of this research will provide the valuable information for power utilities in Malaysia to calculate estimation energy losses in easiest and quickest and efficient way. So thank you.
All right, thank you, Diana, for the presentation. So we open to the panel if any question you want to ask to the student. Okay, please, Prof. Nanta, any question?
Yes. Could you explain again figure 2? What the confidential of this graph?
Confidential.
Yeah,
Okay.
yeah.
So this equation is only for this base case feeder.
Yes.
So if from here we can find the peak power losses, the energy losses. But if we want to find at other places, we have to change this one, and then we have to change the load profile also. So we can from after we change this some characteristics, from here we use a Dick Silent, and then we will get a certain value, and from that value we can produce this regression equation. So if we want to use in a different area or different country, we have to change the base case feeder, but the technique is the same.
I see. Okay. Yeah, thank you.
Oh, okay. Okay, then we seems like associate from Makata eager to ask. Then I welcome him to ask the question.
Yeah, just a small recommendation. That is, you see
Okay,
like
recommendation.
from figure 4, right? So for me, it is quite difficult for reading the letters in your figure. So better you can like enlarge the
Alright.
the point like to to manage your figure again like that. I mean like that. To like a text, your text in the figure 4 is quite difficult for reading like that. I mean only like that.
Yeah, I get it. Thank you for your
Yeah,
comment.
yeah.
Okay, next maybe we just call upon Dr. Apidat if available.
I'm here. Okay, for figure 2, I understand that this show the regression equation, right?
Okay.
Can you inform me about the error of this equation or R square?
Yeah. I
Yeah, this is the
square.
question from
I may
Professor
call the
Nata.
wrong name
Yeah.
a moment ago. Yeah, thank you, Dr. Afidel.
Oh, the R square for this equation.
Yep.
Okay.
R square show the error between the mature data and the graph. They are fixed or not. So we can see by we can consider R square.
Okay. I did find the R square, but I didn't put it in here. So the R square is important for me to put in this graph.
Yes.
Oh, okay. I didn't take that into consideration.
Okay, please add R square information inside the graph in the future. I think
All
it
right.
is good. Yes, it is good for you and the viewer will understand the meanings better.
Okay.
Thank you so much.
And this graph is very beautiful. I mean, it's very ideal. So I'm not sure with the real condition what will happen because the graph is very ideal. You understand my question? Like when in the real condition we have another variation in material, in condition, or anything. Yeah, and at that time you will get the beautiful graph like this. I'm not sure.
Oh, okay. I understand because this graph is actually depends on this simple base case feeder.
Yes.
That's why the graph looks beautiful. But I did do several base case feeder actually for my other paper, and the graph is almost the same figure like this.
I see. Okay. Thank you.
Right.
Okay, thank you, Prof. Nanta. So I not miss Dr. Apidat, I not miss actually Professor Bakata. So turn back to me for the last question.
Yeah.
So
I looking
I give
for
first to the PSU.
another Dr. Kulapat.
Okay, it should be no problem. If Dr. Kulapat want to, if she available, no problem.
Yeah. Do you have any comment?
I'm sorry, like I think my other comments is good and not
Yeah. Just
I'm
It's okay.
I'm
It's
like
okay.
surprisingly
just
that
mention that
I
you
hear my
join us.
okay.
Thank you.
Maybe next presentation.
Prof.
This is the last this is the last presentation, right?
Yeah, correct. This is the last presentation. Prof. Melapat, Prof. Nanta just want to check you whether you are still available or not.
No, I saw her, but not introduced to
Okay.
you yet.
Okay, Diana, can you go to your abstract? Can you enlarge your screen, specifically for the column of abstract? Okay, can you go? Okay, line number after that 10% deviation. Sorry.
Okay, this one.
Okay. Okay. Your sentence related to the with this model. Okay. That one with this model. Actually, based on this abstract segment, which model are you referring to?
Representative load profile model, and this
Okay.
one, this
No.
feeder.
Because what? We at first we will read your abstract.
Okay.
Okay. So this model you are referring which part in the abstract? This model are referring to somewhere statement in the abstract.
Oh, okay. Understand?
You get what I'm trying to say, Diana?
Understand.
Kan. It's a
Yes.
very it should be macam maybe one or two line you are mentioning about the model, and then at the end of the sentences, then you try to refer back that statement to match with your agreement, which is the approach of steam energy kind of this one.
Maybe I
Okay,
lost the word here.
okay, that's the detail of sir tau. Dia macam level macam
I
tu.
lost the word here. Base case feeder model.
Kan, so that dia macam it interrelated. It's not suddenly it appear with this model, but we cannot find the model in the abstract at least. Okay, maybe one sentence or two line just to mention what is the model, then you try to mention the model referring to that kind of cases. Then it should be much more better in the form of writing the abstract.
Okay.
All right. So only that's all for me. Thank you very much. So you can stop sharing that one. I think we maybe have a wrap-up session because now is 4 p.m. at Malaysian time. Okay. Before I start, I think maybe I would like to welcome on behalf of the PSU, Prof. Nanta to give any wrap-up session or conclusion by having this session, because if you notice, this is maybe the last academic session. Okay, because tomorrow will be only the leisure of viewing the Malaysia for the PSU student. So that I mean, this afternoon, I mean, towards the end, we are most completed the version of the academic wise in terms of the content. So I think maybe the best way to deliver your speech in terms of the wrap up for this program specifically, then I would welcome Prof. Nanta to deliver his conclusion remark for today's session.
Okay. Thank you for give me the honor activity. Okay. Yeah. I very appreciate this activity because many good work that I saw from UTeM, very good, that I also learned many students have spin-off company. Yeah, very surprised. And yeah, finally, I would like to thanks to everyone to join this activity, and hope in the future we can visit UTeM and has the good activity like this. And thank you to everyone, Dr. Apide, Dr. Kunlapat, Dr. Makta, and our staff, and also Thai and Malaysia especially Doctor. How I call your name, Muhammad? Could you?
Okay, I will try to pronounce my name slowly and
Yes, yes.
steadily. Muhammad
Muhammad
Afza
Afsa
Nizam.
Afsam.
Boleh lah.
Yeah, yeah.
Okay, okay. Go
Yeah.
ahead, no problem.
Yeah, thank you. Thank you very much for hosting this activity. Yeah. Okay, that's on my pleasure to give you. Thank you very much.
All right, thank you very much, Prananta, for the closing remarks. I think maybe I will try to invite anyone from the PSU side as well. If anything you want to say before we officially close this session, I will try to go around first lah. I will start with the Prof. Kulapat, if any.
Yeah, yeah. Dr. Kunapas is the hard worker.
Iron lady.
I try to say your name again. Muhammad Afan Nisam.
Okay. Better sound. Okay, better sound.
Okay. Yeah. We are. Thank you so much, and we are glad that we can make an collaborate activity together. Like since last 3 years ago that the COVID happened. Yeah, and hopefully like we can continue this collaboration like together and still like we start. I think this two chance for us and our students to extend, because I think five years ago we do just in our department like industrial engineering, and now we can extend to the faculty. So I think we can do this together and keep collaborate not only for students but maybe on the research.
All right.
Thank you very much.
Thank you very much, Prof. Kunlapa. Okay, I think
some students to speak Thai also.
I would offer the speech as well to the Associate Professor Makatar, if any single word for the student.
Yeah, thank you.
Afterward, Dr. Apidat.
Yeah, thank you. Actually, at this time, it's quite difficult for us especially in the PSU, because we have like suffering with flooding. Yes, but inshallah, in next time we try to make it better from our side. Okay, like that. Thank you.
Thank you, Associate Professor Makatar, and maybe any last word from Dr. Apidat.
Okay, thank you so much for your invitation. For me, first I would like to thank everyone for presentation. In my opinion, our work are so interesting. That is first. And the second, for you, thank you so much for everything you have done for us. Thank you so much.
For me, or I mean, for us, I mean together. All right. Okay. I think we already covered most of the representative from PSU. Maybe I would like to call upon any student, maybe one or two student. Maybe you can open your video or camera, and then if you want to say something regarding this session before we officially close this session. Anyone, Prof. Yu? Fai, are you available? Okay.
Hello.
Already standby, Fai, yeah? Okay, good. Okay. We only see your chin. Okay. Okay.
Okay.
Alright. Okay, better.
So after all, I would like to thank from PSU staff and Dr. Auza for successing this evening activities, which is the presentation. So all the comments and all the presentation is very thoughtful and very useful for us to make our paper more convincing and what to say. After all, I want to say very thank you so much for spending your time to join our program, our mobility program. So I'm myself the representative for the postgraduate club. I would like to thank you for everything from our on-site. We are going to Thailand, that you are brought us to PSU University. Then we are playing football and anything. Then until today, you still give your time to spend with us and sharing anything that regarding for our studies, for our paper, journal and anything. So I would like to thank you so much for everyone. So this one is the first place. So I think that's all from me. Thank you so much, everyone.
All right. Thank you very much, Faik. Okay, I think maybe for the last, before we go for the photo session, me myself, let me pronounce my name again. My name is Muhammad Afzanizam bin Muhammad Rosli.
Afzanisam. Yeah. Yeah, yeah.
Okay. On behalf of the University Technical Malaysia Melaka, would like to convey our highest gratitude and appreciation from the team from PSU, especially from the Prof. Kolapat, Prof. Nanta, Prof. Mataka, and then Dr. Adipat, and also all the beloved students from UTeM and also from PSU. So as a host for the online, because I'm not going to the physical site last week, if any problem or this that not meet your expectation, or maybe there's a problem here and there, I will upon the case of apologize for having that kind of situation. But then I already try my best to assure this program running successfully according to the tentative that we committed previously, and hopefully we are running in a good timeline, and yet we managed to reach until the end. Nothing much to say, because I think this is a very good experience for everybody, and I think same goes to the PSU side. The best that we can offer is that the benefit to the student. This is the motivation for us to continue to persistent conducting this event, because I think the student will get the most benefit from this activity, and then we will try to continue this spirit for the next following batch, perhaps, or maybe for the next following team. Okay, don't forget to bring me as well. And of course, till meet you guys again. And before we end the session, I will request all to the student, may open your camera, and we will take the ultimate and utmost session of photo for this online session, day 2 online mobility program UTeM PSU. All right. So, those anyone can open your camera. And then we have the AJK camera, right? That you can try to take the photo as well. Okay.
How I want to post when I have to take the photos.
Okay, everybody smile. Okay, counted on 3. 1, 2, 3. Okay, that one is the official. Oh, seems like not official because already freestyle. Okay, doesn't matter. I think there should be the second round. This one is the real freestyle. Okay, so hold on. Okay, I will try to check the best position of this prop. Okay, hold on. Okay, for your information, for the PSU team, I record this session, and later I will share you the recorded version for your reference and maybe for your student later. Okay. So no worry on that. Okay, so prepare for the second freestyle session. Okay, smile, big smile. Okay, one. Wih, betul-betul big ya. 1, 2, 3. Alright, nice. Alright, so Damia, open your mouth. Okay, no problem. Okay, so with that, guys, thank you very much. So again, this thing can't be happen without your participation. So with that, thank you very much. And then looking forward for the next event with the PSU. And maybe for the student, may leave the session because I have another short meeting with the PSU representative regarding your marks for your presentation just now. With that, thank you very much, guys. See you guys around at the faculty.
Yeah.
Don't forget the kitchen HATYAI for sir. Dah lemak rekod. Okay.
Kutip salah satu, doktor.
Selamat.
Okay, I will stop the record session. Bahaya ni dah nanti.